All right, let's look at another proof technique called indirect proof. All right, so let's say you have two theorems, theorem 1 and theorem 2 is given. Theorem 1 says that the R implies not P, and theorem 2 says that the S implies not P. And we know that there are only three logical possibilities, R, S, or Q. Alright, then we want to prove that P implies Q. Alright, so let's write the two-column proof here. Alright, so line number 1, we're going to start with the given. So we start with P. Alright, then so this is the given. Alright, then line number 2. We're going to list all logical possibilities. So it's going to be either R, S, or Q. Right? So I'll just say all possible cases. So I'll just say all cases. Alright? Then what we're going to do is we want to conclude that the Q is true. So we try to eliminate other cases. So other cases are either R or S. So if we can eliminate R and S, then it automatically tells you that the Q must be true, right? Because there are only three possibilities. So 3. So what we're going to do is we're going to assume, say, let's look at R. So assume R, which is our case number 1. Right? If you know that, so R is true, by theorem 1, we know that not P must be true. So this is according to theorem 1. Right? But you can see that this is a contradiction because this line number 4 contradicts line number 1 because P has to be true, so not P cannot be true. Right? So this is a contradiction, which means that we eliminated the case R. So this is eliminated. Right? And then we look at the second case. So you have 5. Right? Why don't we assume S? Alright, this is our second case, so I'm going to call it the case 2. But according to theorem 2, we know that S implies not P, right? Again, this contradicts line number 1. Right? Then last line is actually, therefore, since we eliminated the other two cases, there are only three possible cases, Q must be true. Right? So this is called the rule of elimination. And I'll just indicate that this was the last case, case 3. Right? And Q is the conclusion we want to make. Right? So this is the outline of indirect proof, and this is so if you know all possible cases, you have a particular conclusion we want to make, we try to eliminate all the other cases, and that way we know that the conclusion we wanted to make is actually true. Right? So this is called the indirect proof. Right? That's it. I hope that this was clear.